Okay, y'all come on. Okay, this machine was originally built in around 1920s. It's called a turret mill. It was a manual machine. It was used to manufacture turrets on the Sherman tanks. And after World War II, TVA got the machine, and it had a big old power generator in the back to run the DC motor. We removed that and put in a new unidrive DC spindle system. And then we also made this one axis, a full CNC. I can't start the spindle because it's not bolted down. But you can see on the manual side, they've basically tagged it out and quit using it and have gone completely to the Centroid CNC side of it. The servo motors on this particular machine are 650 inch-pounds running through a 10-to-1 gearbox. And we designed the ball screw feeds it originally, or the ball screw seats. It originally had rack and pinion feed on it. You can see the rack and pinion feed on the other side. And then this part fed from a worm gear, and we actually added the ball screw out on the front of the machine for the Z-axis to go down. And this machine is not a machine that will hold plus or minus a thousandths or two. You wouldn't expect it to. It's so big. You know, it'll change 2 or 3 thousandths with the temperature of a day's worth of running. But when you deal in parts of this size, you don't expect to hold plus or minus a thousandths. That's pretty simple, isn't it? Oh, when you do a large machine like this, the only thing you've got to really worry about is not undersizing the motors. The DC motors have a whole lot more torque down slow than an AC counterpart. A DC 40 inch-pound motor seems to be a lot torqueier than a 40 inch-pound AC motor. So I really try to oversize it.
That's what I was going to ask. If you actually engineered through parameters what those motors do, or
Oh, I'm sorry.
You just threw a lot of horsepower at it.
No, I have a pretty good idea that it takes about 1,800 inch-pounds to run a machine this size. And I work it backwards. So if you look at a 650 inch-pound motor with a 10-to-1 gear reduction, and then I also pick up the reduction of the ball screw, it's a .375 ball screw. You know, that acts as a gear reducer. So if I think I feel like I need 1,800 inch-pounds, I'll probably throw about 4,500 at it, because the only time it needs it is in that slow initial start. After it gets moving, you know, it doesn't take anything. But when it's setting still, all the oil's out of it, it takes power. It's called breakaway torque. And when you do a machine like this, that's where the problem of the retrofit comes in, is the breakaway torque that it takes on an AC motor. So, you know, just really throw some power at it.
So if that was a DC servo, it would have been a smaller size.
It would have been probably half size. Then the spindle drive system, and I imagine Terry has seen one of these old systems. The original spindle drive system was built up and over this pit, and it was actually a DC generator. It had an AC motor that turned a DC generator to fix this. Well, we were able to replace all of that, if I can find my pocket knife.
Reliance unit.
That's 100 horsepower or 125 horse, and I'm not exactly sure, but see, it changes with the voltage you put in it. We're putting 480 in it. Exactly. So that same drive at a 240 input would be a 50 horse. We do good work, don't we, Keith? No, we built it. We built that right here on site. Well, we just need to say that this is a 10-foot diameter positioning C table. The way it operates is when we type in M51, it drops a set of clutches out from the main spindle motor and engages clutches in a small servo motor.
How small?
It's pretty small. It's that big around, that long. But you know, it's running pretty fast. It runs through a heck of a reduction.
Is that going to show up on, you go to your setup now, is that C-axis going to show up there and you can reference it wherever you want it?
That's what they're working on right now. They're working on that software to where we can go over to setup, and if we want to tell it we're at 3 degrees or whatever, because you know they've got funky degrees off on their prints about putting holes.
Okay. Right.
Positioning. I definitely, when we get a lathe video, I want you to make sure that this is on our lathe video, because proof's in the pudding. We won't try to make a tool change since they have the grinding head, but see, there's a 12-position tool changer over here too. Handle that real carefully. This is solid graphite. It's used to, you put it on a ram EDM machine and burn it down into steel. That machine cuts that.
That's for what, extrusion?
This is for extrusion. And I think there's a lot of applications here for this machine that we can do with that. We got to talking kind of out of the box, what would it cut? Have you ever seen anything cut glass like that? Is that not unreal? It's a diamond. It has diamond. Crank up and let her run.
Just let her run up and down.
Yeah. These machines were sold in the 80s by a company in Japan called, well, Sodic bought the company out. Before that it was Jeff? JPEX. JPEX made these machines in the 80s. They sold them for $120,000. They probably sold 300 or 400 in the US, and they've just been recycled. I don't think there's anybody right now in the US selling these machines but us.
Is there any reason they have so much mass in that reciprocating head? It seems like
Just you have to pull that diamond wire up in tension. You take a torque wrench and torque it. You can go ding, 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 you know.
right.
And
It doesn't deflect.
so, and then you can cut exactly so it doesn't deflect. And it will cut apart within a thousandths. It'll saw that dude out within a thousandths. It'll cut glass within a thousandths. But we run 5 volts through the wire, so if it breaks at night, it puts it in feed hold. Then the operator can come in, put a new wire in, hit cycle start, and it just picks up and goes on.
Or Smart Search would do the same thing for them.
Smart Search would do the same thing for them. We wanted to be a little fancier than that. We wanted to put it in feed hold. Hell, you can just do all kinds of things with a Centroid. See, ceramics will not wire cut.
No,
It will-
use a diamond.
It will saw ceramics, it will saw glass, it will saw beryllium copper. And now that's defense shit. You know, just about all your missiles going up are beryllium. It's so light and brittle.
There's a couple of them out now. We're playing with one that has it right in the keyboard for M15s.
Right back here, this is the reason we stopped here. These are Devlig jig mills, 4-axis machines, and G&Ls are made the same way. This is the W, of course the spindle is a Z, Y is up and down, and X is back and forth. We were able to shrink all the electronics right here into this one cabinet. Now this retrofit's probably 5 or 6 years old. It's one of the first boring mills we did, or I did. I did this one by myself. They sure do. That's one nice thing. In fact, on a machine that has an axis running up and down, you need a regen on it. Roger, we getting you on camera, babe. Huh? Are you not dressed nice enough? Would you jog this dude up and show him rapid and some of this stuff, how it all runs? Basically now on this machine, we used existing motors, pull the resolvers off, put encoders on, pull the encoders right to the Centroid, and all of these axes are 100 amp systems. Okay, y'all come on. I want to show you the first tool changer Centroid ever ran.
Always working at it.
You're damn right. They're fairly inexpensive. They're about $800 a lick. Yeah. They have had to replace the Mazaks here for finishing with these machines. The Mazaks are so sloppy now. They've just wore the damn things out. Now they're doing their finishing work right here. But now they're about $180,000 a piece. These are $40,000 a piece. It's a nice change.
Some of these are sold with manual control. 500 control.
First retrofit.
Lord. Oh my Lord. Jeez. How old? What year? What
God, I don't know, 84?
Still running, huh?
Still running, making electrodes.
Oh, and
This is what I showed you, right?
this is 100 a quarter way back when.
$120,000 in the early 80s. That was the first Centroid retrofit I ever did.
That was just a machine? For making test boxes and stuff? Wow.
That's unbelievable that saw's that accurate.
Yeah, it's like it's absolutely amazing.
That's aluminum extruder. Any aluminum extruder or die builder has to have that machine. And see, that's extruded in a big long rail. So that looks like maybe a storm door.
Like I said, that looks like a
Storm window, storm door. That's some good video. Let's see what they're doing here. That's a pretty good sized little mold, isn't it?
Wow.
This end mill goes all the way through this piece of tool steel and supported at the bottom with a live center.
Nice.
Exactly.
Wow.
Now they grind the center of it?
No, the end mill manufacturer leaves the center. All end mills have a center and they cut it off and put a bottom. They just leave the center.
Okay.
Sets down, and that way they get it's the way to do it.
Right.
It's absolutely the way to do it. That's T15 with the 6-position turret. 10 horsepower, 3-speed geared head. The lathe comes standard with a 6-inch diameter chuck. We also put 5C collet sets on them. This is a great production lathe. I mean, absolutely excellent. Oh, you gotta have it. This is your W. That gets everybody's big old attention, doesn't it?
What'd you ready to fit this one for?
Oh, it's 108,000. Is that not awesome? Now, we set the probe, you can see up by the coolant switch.
Yeah.
That's where he plugs his probe into. He uses his probe to pick all these up with. Keith, 120 inches in X, 94.5 inches in Y, 36 in Z, which is the quill. The W is 50 inches and it's a 50 horsepower spindle with a 4-speed gear range. This is an old Pratt and Whitney CNC machine. And of course, you can see the reason we went with this machine is the size, molds that it will do. That's a pretty good sized little mold, isn't it? I don't have a clue. Let's see if the print says. What is this mold for?
Our table capacity is 15,000 pounds, and that's what the raw block weighs.
The raw block weighed 15,000 pounds. That's the capacity of this machine. What does this part make?
It's part of a rubber mold.
Part of a rubber mold.
Yeah.
That's a heck of a piece of rubber, isn't it, Mike? Golly.
Yeah. It builds a gate for TVA, a gate valve.
Okay.
Part of a gate valve for TVA.
Hey, Billy, can you drop this down to Windows while it's running?
Yeah, Control C.
We couldn't have come in a better time. That is a hail of a mold on here.
Yeah, I wish I had 2 more foot of travel and I could have got her on one setup.
God. Are you actually having to flip that thing?
Yeah. And not only that, when we get done flipping it, we've got to rotate it. There's an undercut in this thing. It's a rubber mold. Big, isn't it?
It's huge.
Can't imagine anybody buying gate valves that big.
TVA? Home, James. The tour is over.